Hey there, welcome to the Electronics Lab. In this video, we're going to look at series circuits. And series circuits are ones where the devices or components are connected back to back to back, kind of like these resistors are here. They're connected one after another, and electrically speaking, these components have to have the same current flowing through them because there's nowhere else for the current to flow. You can think of it like if you have garden hoses connected together. If you have those hoses connected together and you turn the water on, there's only one place for the water to flow. It's got to go through the first hose and then through the second hose. And so those two garden hoses will have the same current. Same with these resistors. They're connected back to back. There's no other place for the current to go, so they will all have the same current flowing through them. Voltage across devices in series is summative. And what that means is that the total voltage across this set of devices is going to be equal to the sum of the voltages across each one of the individual devices. So if I have voltages for each one of these components, and I have a voltage across the whole circuit, that total voltage has to be equal to voltage across R1 plus the voltage across R2 plus the voltage across R3 plus the voltage across R4. And this rule applies to all types of devices. It could be voltage sources, it could be diodes, it could be capacitors, it could be inductors. The voltage across the entire set of those devices that are in series is equal to the sum of the voltages across each one of the individual devices. As an example and a special case, if I have voltage sources connected in series like this, the total voltage is going to be equal to the sum of the voltages. So I've got 10 volts plus 5 volts plus negative 6 volts. So the total voltage across it will be the sum of the voltage across those voltage sources, and I get 9 volts across the three of them. One caveat is that current sources can't be placed in series. If this is a 5 amp source and this is a 1 amp current source and they're in series with each other, they have to have the same current through them. But is it 5 amps or is it 1 amp? It can't be both at the same time, so it's hard to say what the current's actually going to be. In reality, non-ideal voltage sources will have some kind of shunt resistance across them, called out RS1 and RS2. So these could be placed in series. There's going to be some unknown thing that's going to happen because that 5 amps, some of that's going to go through RS2, and some of it maybe is going to go through RS1. So there could be a significant voltage drop across these two. Don't really know what's going to happen. So current sources typically don't get connected in series, and if they do, you'll have unexpected results. Now let's take a look at this simple series circuit and see what kind of analysis we can do on it. Well, on the voltage source, we have a positive side here and a negative side here, and we know that conventional current will come out of the positive side through the resistors and back to the negative side. Let's call that I. We know that the voltage across the resistors will be positive on the side that the current goes into and negative on the side that the current comes out of. We know that the current from the source is equal to the current through R1 equal to the current through R2, and I've just designated that as I. So we've got a current that's the same through all of the devices. Well, from Ohm's law, we know that the voltage from the source is going to be equal to that current times whatever total resistance the source sees. We also know that the voltage across R1 is going to be equal to the current through it times the resistance R1. And for R2, the voltage across R2 is going to be equal to the current through it times the resistance of it. We also know that the voltage from the source is going to be equal to the sum of the voltages across the two devices. Now if I take these expressions and plug them into this equation that I've got here, I've got I times RT is equal to I times R1 plus I times R2. Now, if I divide both sides of the expression by I, those I's go away, and I get total resistance is equal to R1 plus R2. And this, for this specific circuit, applies to all series circuits regardless of how many resistors are in them. The total resistance is going to be equal to the sum of the resistors that are in series. So in general terms, for any series resistance, the total resistance across all of those series resistive elements is equal to R1 plus R2 plus R3 plus all of the other resistors up to the very last one, Rn. And this right here is one of the fundamental takeaways that you can have from this video. When you have resistors in series, the total resistance across them is equal to the sum of all of those resistors that are in series. So I hope that helps with your understanding of series circuits. Thank you so much for watching. See you next time.